Thank you, and it's wonderful to be here. It's interesting going last because I've been tempted to rewrite this through the entire conference, and in some ways I feel like I'm the 16th course of a 16-course meal. So either I'm going to be a very heavy dessert or perhaps a digestivo and allow us to move on. But I'm also know that I'm standing in the way of from our intellectual meal to a biological meal, and so I will try to be concise. What I want to talk about today are different models. I'm going to back up in a way, move out to the 30,000-foot view. We've had a whole range of really fascinating and deep conversations about ways of diving into this material and exploring the intersection of our disciplines. But I want to back out to a distance where we can think about what is the kind of model of how the world works, how the body works, that we carry in our heads that actually determines the way we design, the way we diagnose, the way we work on, go about the business that we do as architects, as doctors. We don't operate on the world in relation to the world as it is. We have no direct access, in a way, to the world as it is. We perceive it, we interpret it, we build models of how we think the world works, and then we design, we diagnose, we operate in relation to those models. It's fundamental to how we are as humans. In some ways, I inadvertently demonstrated this last night at the Palladio Museum in front of the Tiepolos when I asked why the image was asymmetrical until I walked around and stood in front of it and realized that that image was actually perfectly symmetrical. And it's a phenomenon of trompe-l'oeil paintings and their construction of perspective that when we view them from different angles, the painting seems, or the fresco in this case, seems to change, because our mind is interpreting that information in relation to what it expects to see and then reframes it. Our eyes and our brains are not cameras. They're not recording something as a direct projection of the world beyond. We are interpreting. And in a way, that is a simple example of a kind of visual perception that sometimes gives us miscues about what's going on. But if we back that out to a larger framework, we have a constantly evolving model in our minds individually and as cultures, as civilizations, that guide us in making decisions, in thinking about design. So I'm going to very quickly run through a few different models of the world, and I want to see this not as a sequential series like the progress of humanity working towards some higher goal, but actually as a cumulative series, because the old ideas don't die. We're still dealing with questions that were being wrestled with 500 years ago. We're still dealing with those models of how the world works in different ways. So we can think about history as a cumulative rather than sequential act that give us a kind of complexity in the way that we work in the world. We often frame the work that we do in relation to, it's something that comes up constantly in academia, work that I've been doing in our Office of Vice President for Research, of how do we tackle complex, difficult challenges. We often frame these in terms of problems to be solved, or how we measure human progress, or how we take this on. If we do that, we can see an extraordinary change. The simple map of global life expectancy. We can say that the models that we've used, the kind of scientific progress, have given us a set of tools that have fundamentally changed how human beings live on the earth. We can look at this across a whole series of measures, and in a sense, we are better off, perhaps than in many ways, by many measures, than our ancestors were historically. Life expectancy, wealth, the domestic product per capita globally. You'll notice that the line doesn't change here. They are approximations. I actually have another slide that I didn't include that has all the charts that are the data behind these, but we see this in the last couple of hundred years, dramatic changes, global connectivity, dramatic changes in how we operate. So what's the problem? We seem to be making great progress. Although, as Aaron reminded us, we may be hitting some limits on some of those as our biological evolution runs into the actual ways that we've constructed for ourselves to live. And there are side effects, the things that get left out sometimes of our models, things like, this is we need a little less light here, but that's global carbon emissions, for those who can't read that, the global mean temperature, global energy consumption, global population, global rate of species extinction. There are a whole set of questions that have a fundamental bearing on our life as a species. And it provokes a kind of an interesting question that, as a way of thinking about what Vitruvius articulates in the beginning of his 10 books of architecture. The architect should also have a knowledge of the study of medicine on account of the questions of climates, air, the healthiness and unhealthiness of sites, and the use of different waters. For without these considerations, the healthiness of the dwelling cannot be assured. And in this case, I'd like to back it out to the global dwelling, that in a sense, most of the challenges that we face in a kind of global sense in humanity, we can trace back to choices that we make about how we live, choices that we make about the structures, the cities, the systems that we build for ourselves to inhabit the planet. So when we do back out to that larger lens, the models that are governing the choices we're making as designers at the scale of the body, at the scale of the building, at the scale of the city, have a profound influence on the challenges that we face now. Leonardo has to show up in every talk on this kind of subject, and the text is simply the text from Vitruvius that Leonardo was, in a sense, doing the illustration for. But it's not quite that simple, because, of course, what that diagram represents, and we've heard different descriptions of it, different versions of it, but it is a representation of an idea of the idealized body, as Lewis talked about earlier. The idealized body in the world is a representation of a divine, a platonic, a geometrical order, but the fundamental idea is here is that, in this case, it isn't about the body and its physicality, but it's about the body as representation of something ideal and something beyond. And in a way, that mode of thinking about the body continues to animate architecture. It continues to cause us to look for not just bilateral symmetries, but the greater notions of symmetries as harmonic relationships among all of the elements, as the body has all of those elements. And that kind of representational mode, that understanding of perhaps and sometimes an assignment of a kind of instrumentality to form, that if we think we make beautiful buildings, we will make healthy places, is one of the animating strains of architecture. And on a certain sense, that aesthetic dimension is fundamental. It hasn't gone away. It is still active. And as Phoebe and others have spoken about, it is central to our understanding of the relationship of design, a relationship of architecture to the experience of the world. It also animates, in a kind of literal sense, a city not far from here, Palmanova, which has both a kind of defensive geometry as well as an idealized urban geometry that reflects that kind of city, building, body as representation of a divine order. Palladio introduces another description of the body beyond those of Vitruvius and Alberti, which is interesting to me. I've always been fascinated by this passage where he says, for the human body, there are some noble and beautiful parts and some rather ignoble and disagreeable parts, and yet we see those who stand very great in great need of these, and without them they could not subsist. So in fabrics, there ought to be some parts considerable and honored, and some less elegant, without which the other could not remain free, and so consequently would lose part of their dignity and beauty. There's two things. One is the necessity of understanding the whole, but the other is that there is a hierarchy. In a way, this speaks about something that is essential to classical architecture, central to Palladio's architecture, which is the articulation of a social or cultural hierarchy, not only within the buildings, but also within society, which is also, and bringing it back to this description of the body in those kinds of hierarchical terms. As we move forward and we start to overlay the introduction of scientific methods, both of exploring the world beyond and of measuring the world and measuring the body as we move forward, we start to see that mode of thought in a way, this kind of overlap of not only architecture in a representational mode of describing of the form describing some idealized order that lies behind the surface of everyday reality in a kind of Platonic sense. But we also see it as being instrumental. If we start to apply these kinds of mechanics, these geometries, a kind of Newtonian understanding of the world as in a kind of mechanical terms, we can start to see the body laid out, and I always love this pairing of the body laid out on the surface and looking at its guts, and a county in Iowa, where in the Jeffersonian grid across the United States can be understood as a kind of formal organization, a kind of mechanization using the grid of measuring, of actually transforming the land from a set of natural systems to a set of systems that can be then subdivided, ordered, governed, sold, commodified in a sense. In a way, a kind of mechanization of the nature that is in a way related to an understanding of the body as a machine, as something. And even in architects from Frank Lloyd Wright to Ebenezer Howard who were looking at a kind of search for a new kind of relationship to nature, of a city and a landscape that was a reaction to the industrial city, the industrialization of 19th century cities in Europe and the United States, and thinking about a different kind of relationship. In a sense, there's an underlying mechanistic order of the separation of functions, of the thinking about the parts and the pieces as being able to be diagrammed into a kind of mechanical order. Another representation of the body with Le Corbusier, and I'm just running through a really quick set here. This is an entire course if it wanted to be. It is actually in another setting. That we start to see, in a way, Le Corbusier get very explicit, particularly in his more polemical projects about urban form. There's a big distinction between his polemics in these projects and the richness and complexity of the buildings. But this diagram, which is difficult to read from a distance, but is the one on your left, is a diagram for an idea about housing of and the separation of a building and a place that is ordered by, across the bottom, the telephone, gas, electricity, and water that are all funneled in as mechanical systems. So our relationship to the world becomes purely visual, so that in a sense there's this separation of all of those systems and services. And in a sense, the city becomes a representation of the body in a kind of mechanical sense, and we start to see this kind of mechanistic overlay here that then translates into the city as a set of detached systems, nature as simply a visual, in a way, setting to put these mechanized objects in. The image on the bottom is actually from a children's book that I discovered when I was going through my old books for my own kids. Published in 1957, it says Billy Sherman on the top, that my mother had written in, and I keep wondering if this book had something to do with my career. But at the bottom here it says, someday skyscrapers would take place of all the old buildings. Everyone would have plenty of sun and light and room to work and play. And I see this as a kind of cautionary tale sometimes when we think about this kind of singular mechanical notion of how we think about cities, because there are other images in the book, like the streets were crowded with many small buildings close together, and the next image, which I'm not showing, is the tearing down, the razing of the building to create this new landscape in which the towers could sit. And of course, that was going to be done by the architects. 1957, you know who's at the table. I like to think the woman who's put there in the corner as the secretary is actually Jane Jacobs, who is going to upset the entire industry by what she's writing on the side. But we're familiar with the plans that, in a way, this mindset raises here with, again, another one of Le Corbusier's polemical projects for Paris, but which we built in the United States and in many other places, in that kind of reductive model of human habitation. Now, thinking about these kinds of sequences of models of thought, you've got to think about Lewis Mumford and his writing in Technics and Civilization, where he's looking through the kind of ages of technological thinking. And this is a particularly interesting piece to me, that the humane arts of the humane arts of the physician and the psychologist and the architect, the hygienist and the community planner have begun in the last few decades to displace the mechanical arts from their hitherto central position in our economy and our life. Form, pattern, configuration, organism, historical filiation, ecological relationship, and concepts that work up and down the ladder of the sciences, the aesthetic structure and the social relations are as real as the primary physical qualities that the sciences were once content to isolate. We now realize that machines, at their best, are lame counterfeits of living organisms. Our best electric lamps cannot compare to the efficiency with the light of a firefly. Our most complicated telephone exchange is a childish contraption compared with the nervous system of the human body. This was 1934, and we think of this shift as taking place just in the last couple of decades. Sanford Quinter, the theorist, pointed this passage out, which I had read that book as a student. I had it, but I somehow missed that little nugget, which really is just a kind of nugget in passing, as Quinter points out. And I won't read Quinter's quote, but he's actually talking about, okay, he was recognizing this in 1934. Imagine how things have evolved since in our understanding of the potential of rethinking the mechanical to a biological paradigm for this. And of course, that leads us to actually a science that didn't even exist. It was the science that was the foundation of Jane Jacobs' writings in the 1950s, that she was hanging out at Rockefeller University with the people who were actually exploring complexity theory and understanding the kind of behavior of systems in a way, and a new model of thought that was developing a whole new set of tools, a new mathematics, a different way of dealing with the behavior of systems that could not be broken down to constituent parts and then isolated with predictable outcomes. These are diagrams of the internet and of metabolic processes in the body, perhaps two representations of kinds of systems at different scales. And the exploration that someone named Michael Batty has been doing of ways, these are just examples that he was pulling from history, of how we can actually mathematically model the complex behavior underlying the pattern and the growth and the spread of cities. And this, which is a set of diagrams of the use of agent-based models from a group that I organized at the university to come together, but it ranged from start up across here, from people who were modeling the spread of diseases to people who were modeling the sort of social and ecological interactions of in the Chesapeake Bay, to someone in the Darden School of Business who was looking at, and I'm not going to go into these, they're just using as visual diagrams here, the Business School of certain interactions around business systems, to the modeling of the blood vessels in the eye by a biomedical engineer. And architects, and here such as Stefan Banish, and much of what is important about this image is washed out here, which has to do with what happens when one starts to deal with the dynamics and the complexity of the world and the way you can engage those in in the life of a building, and we've seen many examples of those. But if we back out one more step, in a way, which Manuel de Landa does in the 1,000 Years of Nonlinear History, he talks about in the organic world, soft tissue reigned supreme until about 500 million years ago. At that point, some of the conglomerations of fleshy matter energy that made up life underwent a sudden mineralization. The human endoskeleton was one of the many products of that mineralization, yet it is not the only geological infiltration that the human species has undergone. About 8,000 years ago, human populations began mineralizing again when they developed an urban exoskeleton. And I love this analogy, that we actually are taking the systems and the materials that made up the interior of the body and our skeletons, and we started surrounding ourselves with them. Thus, and goes on, thus the urban infrastructure may be said to perform for tightly packed populations of humans the same function of motion control that our bones do in relation to our fleshy parts. We must be careful to avoid the error of comparing cities to organisms, which he's going back to, again, a kind of critique of modern interpretations of cities as biological organisms that gives us so much of our language in the way that we talk about cities even today, to roads as arteries and nodes, and much of our language related to cities, especially when it's meant to imply, as it has in the past, that both exist in a state of internal equilibrium or homeostasis. Rather, urban centers and living creatures must be seen as different dynamical systems operating far from equilibrium, that is traversed by more or less intense flows of matter and energy that provoke their unique metamorphoses. And the key to this part is this discussion of dynamic systems far from equilibrium. In many models of thought that are connected to historically to sustainability, to systems, to bodies even, it's about finding balance, about finding equilibrium. It's about finding a static point. The only point where our bodies are in true equilibrium, in a sense, we might say in a state of complete rest, is actually when we're dead. And that is actually true of cities as well. They operate at a range that is near the extreme. And we go slightly over that range with a fever, not that many degrees for a period of time, and we get kicked into a whole other state. This has a strong relationship to the way ecologists look at ecosystems through models of resilience, which we can see repeated patterns of how those dynamic systems operate that are encapsulated in these diagrams over on your right, that go through cycles of growth, of the kind of conservation and accumulation of energy, a kind of collapsing under their own weight, a dispersion and a redistribution and a reorganization, and then a regrowth again. And systems are going through this constant, whether they're human system, whether they're ecological systems, social systems, political systems, economic systems, they're all behaving according to this same set of patterns. How we operate on those systems and how we engage them depends on how we actually can analyze and think about it. And when we think about it this way, this is completely different than a way of looking at the world mechanically or a way of looking at the world representationally. This is a way of looking at the world as a system of constant dynamic engagement. The other piece of that diagram over there is that there are small systems, we might say at the scales of bodies, that are fast and that accelerate and that push the system. And there are big systems, there are institutions, there are large-scale systems that actually slow it down. And so you can't look at any one system in a kind of scalar isolation, that we have to be thinking about these phenomena as being connected across scales. So in Brian Walker's book, Resilience Thinking, he makes this connection, that he's not just talking about a pond that shifts from being a healthy ecosystem to being covered with scum, or one that is been dried up by a change in a large-scale system like a climate system and is now depleted. But he also recognizes that this applies to human systems, to social systems, to biological systems as well. And so he has a set of principles that I think are actually informative for the way that we think about this thinking across scales that we're doing at this conference, and that I think is essential to how we move forward, saying that we can't manage ecosystems and social systems in isolation. The feedbacks between them have to be taken into account. We have to identify those slow controlling variables that may have a threshold effect, that is, the capacity to push a system into another operating state, into a state where it functions differently. Whether that's, again, a body moving from health to sickness, or whether it's a social system that moves into, in a way, an unfavorable state. And sort of looking for and understanding the drivers of slowly changing variables, being able to figure out where those are going. To understand what's happening in the adjacent scales and the impact on the scale that you're actually focusing on. To identify key points for intervention that can avoid the undesirable alternative regimes, either changing the positions of the thresholds or altering the trajectory of the system. He uses an analogy of a ball rolling around in a basin on an uneven surface. And if the ball stopped, the system's in trouble. So the surface is, in a way, constantly moving. And that surface is the threshold, because at a certain point, either that ball's going to start moving so fast and the system's going to get out of control. It's going to go into an adjacent basin, which may not be a basin you want to be in. And that is that it moves over from one threshold to another. The thing about thresholds is once you go over one, it's very hard to go back in ecological systems. So when we think about large-scale changes, we may have a series of very slow incremental changes going on in society, and we see this in a positive effect, for instance, in the long buildup of the acceptance of gay rights, for instance, and then suddenly a threshold shift, some call it the tipping effect, where there's a kind of sea change. Same thing happens in ecological systems, same things happen in biological systems. But it's actually hard to go back once you move to a new state. It's the only thing that keeps me optimistic right now. And also investing in adaptability. That the way that systems can operate is that they have to be constantly adapting, and at points where it's necessary, we have to start looking at transformation. So I'll bring us back to Venice and adaptability in these systems, and one of the things that has actually been central to my interest and involvement in the University of Virginia's Venice program for many years is that, number one, in Venice, the systems are visible, partly because we don't have the familiar ground and because there's been a reinvention of those systems around a way of life, which is actually the reverse of what we've seen in much of the world, which is a reinvention of a way of life around a set of systems over which we seem to have no control. So in a way, Venice is a really interesting model of you invent the system that allows the city to sustain itself. At the same time, it's at the kind of front line of vulnerability to both forces of climate change and other kinds of forces, but it also has within it, and that's the image on the right, it has a kind of culture of adaptability, whether that is in the terrazzo veneziano with enough linseed oil to allow it to shift in relation to the movement, the constant movement of the ground and the structure, or in the societal kind of cultural adaptations to change. So I will end on that note of we've got some big challenges, but we've got some fantastic models, both historically and in contemporary terms, to work from. But we have to be constantly conscious of what's the lens through which we're looking at the world, and what are the models that are animating our decisions, and how can we, in whatever our practice is, whether it's medicine or architecture, how can we apply those models in the face of complex challenges where we are always going to be operating with inadequate information and uncertainty? So, thanks.